My name is Antonia Harris, and I chose to discuss the action potential of cardiac contractile cells. This is for the Concepts of Human Physiology 2 at the great Grand Canyon University. Yay! So, just a little background on the cardiac contractile cells. So they do make up approximately 99% of the myocardium, which that is just the um, muscle cells. They are specialized for contraction. So basically, the mechanical work of the heart. Their role is to eject blood out of the heart, which provides great circulation throughout the body. And their resting membrane potential is approximately 90 megavolts. So normally they also don't initiate their own action potentials. Now, the other 1% of the cardiac contractile cell, the other 1% of the cardiac muscle, are the autorhythmic cells. They are non-contractile, and they are specialized to initiate and spread the action potential that was generated by the contractile cells throughout the heart. So right here, I just have a diagram of um, of the action potential of the car. Sorry, I had a of the contractile cells. The action potential of the cardiac contractile cell. As you can see, I label each level just so you can have an idea of what I'm talking about whenever I go over the next couple of slides, because I will go over them in detail. This will just give you an idea so you can know exactly what I'm talking about. As you can see, this is time in milliseconds versus the membrane potential, so it kind of gives you an idea of how fast things take place, and you can kind of just see what's going on and how quickly everything is happening. So this is phase one. As you can see, I just took this diagram, the diagram from the previous slide, and I just cropped it so you can have a more generalized area of where, a more specific area of where I'm talking about. So this is also called the rising phase. During this phase, the voltage sodium ion channels are activated. Because of this, there is an influx of sodium into um, into the cell, which then has a reaction for the membrane potential. It pushes the membrane potential. It pushes it up. So yeah. And then on phase two, which will be the peak of um, the action potential, during this phase, there is a decrease in the permeability of sodium on the plasma membrane, because the gates are starting to close. This leads to a transient period of repolarization, and it also leads to the opening of the voltage gated calcium channels, which actually prohibit repolar repolarization of the membrane potential. Because of this, there's a prolonged period of depolarization, and that leads you into the plateau phase, which is going to be phase three. So this is phase three, the plateau phase, like I just mentioned previously. So this is also called the absolute refractory period. It lasts approximately 200 to 220 milliseconds. During this phase, um, there is an influx of calcium into the contractile cells, and the influx of calcium activates the contractile mechanism associated with the cardiac muscle. So basically, it makes the heart contract. So then the last phase that I'm going to discuss is phase 4. So phase 4 is the falling phase. During the falling phase, there is a decrease in the permeability of calcium. So those voltage gated channels are closing. And then there's an increased permeability of potassium. Those voltage gated channels are opening. This leads to a efflux of potassium, and that is what is responsible for repolarization. And then that will lead the contractile cell back to resting membrane potential. And then after it gets there, it just repeats the cycle over again. So then here I just have a list of all the references that I used in order to get all this information for the diagrams, for the information that was included in the slide, for the little extra information that I said during this presentation. Yeah, so thank you for listening, and until next week.